Hello, everyone. Am I audible? Hello, everyone. Hello. Can you guys tell me, am I audible? Hello. Am I audible, guys? Great. So let's just wait for 2 to 3 minutes, okay, so that everyone can join, and then we will quickly start with our session. Hello, everyone. Hello. So, okay, yes. So in yesterday's session, we have done the pre-processing steps, right? That also known as feature engineering, okay, like how do we deal with our data set and how to fill out the empty columns or null values, how to balance the data set and everything, okay, label encoding, data standardization and all. So in today's lecture, that is day 3, we are going to start with the like today there are two topics. The first one is hyperparameter tuning and the second one is ensemble learning, okay. So we have to cover these two topics in today's lecture. The attendance will be taken at the end, so don't worry. The attendance link will be provided to you guys. Good evening, everyone. I hope everyone is ready for the amazing day 3 of this bootcamp. So in today's lecture, we will be starting with like how to train our model and how to improve our model with the help of hyperparameter tuning. Okay. And the second thing that we are going to do is we are going to see the assemble learning. Till then everyone joins, is there any kind of doubt regarding previous sessions, like the day 1 or day 2? Is there any kind of doubt? The standardization is like used to bring all the data in a common range, we can say, okay. So it is a very good practice to standardize your data before training your model. Standardizing and pre-processing is because like the more better your data is, the more better model you will get, okay. Your model totally depends on the quality of your data. I hope the previous 2 days are clear so that we can start with today's topics. Good evening, good evening. Okay, so let's quickly begin with the today's session, that is hmm I hope my screen is visible, guys. Am I right? My screen is visible, right? Great. So my screen is visible. So let's quickly move on to Collab Notebook. How to right now we are using the existing models, okay, for our practice, but we can also create our own models using deep learning. Okay, like in deep learning we set all the neurons and activation functions and everything so that we can create our own models. Okay, so let's move on to first of all training the model. Great. So yes, the very first thing is we have imported all the necessary libraries. I will quickly connect to my notebook as well. So first of all, we have imported two libraries, that is NumPy and Pandas. Okay. In the next step, we have imported standard scaler and label encoder. I have already showed you these two libraries. Okay. The standard scaler is used to standardize our data, and label encoder is used to like if we have categorical columns like this iris setosa and iris virginica, all these columns will be converted into numerical values. So this label encoder is used to convert the categorical column into numerical values. Okay, sir. Then we have a train test split. Okay. Then we have imported train test split from sklearn.model selection. Now, sir, what is this train test split? So actually, before training our model, before training our model, we always split our dataset into training part and testing part. Okay. Before splitting, sorry, before training our model, we split our model. We split our model into two parts. The first one is training part and the second one is testing part. So in the training part, like on the basis of training part, we train our model, and on the basis of testing part, we test our model. Okay, we test our trained model, that our model is working or not, how much accuracy we have in our model and all. Okay, so we have imported train test split to split our model into training part and testing part. Then, sir, what is this XGB classifier, random forest classifier, SVC, logistic regression, and all? So, maybe in day one, I guess. In day one, yes, we have talked about some algorithms for supervised learning. Okay, so these are some algorithms for supervised learning. I hope you remember these algorithm, guys. I hope you remember all of these algorithms. Great. So in these algorithms, we have logistic regression. Okay. In these algorithms, we have logistic regression for classification, right? I will do one thing. I will simply copy this and I will paste this over here in day 3. Yes. So these are all the algorithms that we use in supervised learning. Like not all the algorithms, there are many more algorithms as well, but these are the most commonly used algorithms. So logistic regression is used for classification problems. Sir, what are classification problems now? So the problems in which we have to predict some classes, like whether the gender is male or female, whether it's a boy or girl, whether the answer is true or false. So in these cases, I have to predict some class, right? There is no continuous value. That is why logistic regression is used for classification over here. Okay. Linear regression is used as a regressor. Okay. SVM, that is support vector machine. DT, so what is DT now? So DT stands for decision tree. Okay. Then we have RF. RF is nothing but random forest. And we have XG boost, which is extreme gradient boosting. So these are all the important algorithms that are used for supervised learning. And within these algorithms, suppose I have to train my model on this iris dataset. Okay, I have shown you this iris dataset yesterday as well. So this is my dataset. So in total, I have three categories. I have iris setosa, I have iris virginica, and I have iris versicolor. If I'll just show you, yes, here are the three categories I have: iris setosa, iris versicolor, and iris virginica. So this means this is my classification model. Okay, because I have to predict any of the three categories that are given here. Okay, so this is my classification model. That means I am going to train my data on any of the classification algorithm, right? So I have 3 to 4 classification algorithms written over here. First one is logistic regression, second is SVM, then decision tree, random forest, and XGBoost. So these 5 algorithms are classification algorithms. So why not linear regression? Linear regression is a regression algorithm, not a classification algorithm. Okay. And then we have metrics. So what is metrics? I will explain this later on. Okay. Then we have simply with the help of dot read CSV. I have told you this function yesterday. With the help of dot read CSV, we have taken our data set, and in this I have mentioned the path only. So this is my data set over here. Then in the next step, I have done the pre-processing. So what pre-processing? First of all, we have checked if is there any null value or not. Okay. We have checked if is there any null value or not. So I can see there are no null values in my data set. Then we have seen, like, then we have dropped our fourth column. Sir, what is fourth column? So we have dropped our iris setosa, this like fourth column of ours. Sir, why we have dropped this column? Try to understand. We have to train our model. Okay. We have to train our model and we have to get some kind of output. And my output is nothing but my fourth column. So can we say that these are our labels? Because in supervised learning, we deal with labels. Supervised learning, the definition is when we train our data on labels. Okay, so these output column, this output column is nothing but my labels. So I have separated my labels with my data. Okay, I have stored my data without labels or without the output column in X variable, and I have stored my outputs or my labels in Y column. Okay, sir. So this is my X and this is my Y. Then I have seen the Y dot value counts. This value counts function is used to get the number of data points under each category. So as you can see, we have 50 data points under iris setosa. We have 50 data points under iris versicolor, and similarly 50 data points under iris virginica. And we can also see this is a balanced data set. Then in the next step of pre-processing, we have standardized our data with the help of standard scaler. Okay, I have shown you guys how to do it with the help of scalar.fit underscore transform, and then we can see the standardization is complete and we are getting the standard deviation is equal to 1. All of this we have already studied. Then we have seen how to apply label encoder as well. This is also we have done in the last lecture. With the help of label encoder, what I have done, I have converted iris setosa to 0, I have converted iris versicolor to 1, and I have converted iris virginica to 2. I hope this much is clear now. Then the next step, okay, why I have removed these labels. Okay, so yes, as you can see, I am splitting my dataset over here. Okay, I am splitting my dataset based on, like I have told you that I have to split my dataset into training part and testing part, right? I have to split my dataset into training and testing, right? So I am over here splitting my dataset into training and testing part with the same function, that is train test split. Under this train test split, I have to give two functions, like two datasets. That is, the first one is X, that contains all our input features, and the second parameter is Y. Y contains all our output labels. Okay, so that is why we have to split our input features and output label so that we can train our model. I hope this is clear. Label encoder is used to okay, I will just explain you with example. Suppose I have a data set in which one of the column consists of the state. Let's say Delhi, let's say Mumbai, let's say Chennai. Okay, these are the several states in my data set. Okay, so what I can do, my model is not going to train on these string values or these categorical values. So I have to convert these categorical values into numerical values. How can I do that? With the help of label encoder. So I will move this column to my label encoder. I will send this column of mine to label encoder, and then label encoder will give me a same column in which I will have 01, which will denote Delhi. I will have 02, which will denote Mumbai. I will have 03, which will denote Chennai. I hope this much is clear. Great. So yes, sir. Further, we have splitted our dataset into training and testing part, and we have stored all the values in xtrain, which means input features used for training. Okay, xtest, which means uh, input features for testing. Ytrain, which means output labels for training, and ytest, which means output labels for testing. Okay, sir, what is this test size is equal to 0.2? This 0.2 over here denotes that my test size, okay, the size of my testing data is equal to 20%. Okay, so this means I am converting 80% of my data into training part and 20% of my data into testing part. Then, sir, the next thing is random state. So, random state is equal to 42 means like nothing but you can give any value to the random state. It is just used to like take the data from your data set. Okay. Then, what is the stratify is equal to? Or I can just simply write instead of data set of 4. Okay, don't write this. You can simply write is equal to true as well. Okay, you can simply write is equal to true. Sir, what is stratify now? Suppose I will just give you an example. Suppose in a data set, I have the output labels are like whether the person is male or female. Okay, so this is my output. Suppose I have 10,000 of output as male, okay, and 1,000 outputs as female. Okay, now what if I am taking a test set. Okay, now I am converting this data set into training part and testing part. I am converting this data set into training and testing. Let's say I'm taking 80%. Okay, I will take it as 9,000. Okay, I will take it as 9,000. Okay, now I am converting 80% into training and 20% into testing. Now under training, I will get 8,000 data points, right? And under testing, I will get 2,000 data points. I hope this much is clear now. Okay, at least this much is clear. After that, I don't know, sir. It can be like all the 8,000 consists of male, and in this 2,000, we have 1,000 for female and 1,000 for male. Sir, can this be our training set? And can this be our test set? No. because in this we are only training on male, we are not training on female. Sir, can we take, sir, can we take test set for both 500 and 500, like 500 male and 500 female, and rest in the test training set? No, this also we cannot take. So we have to maintain a proper proportion. We have to maintain a proper proportion such that if total values are 10,000, if total data points are 10,000, in which 90% is my male and 10% is my female, so I have to maintain the same proportion for my training set and my testing set as well. Suppose in training set I have 8,000 images. So in those 8,000, 90% should be of male and 10% should be of female. And in the similar way, in the test set, if I have 2,000, then in those 2,000, 90% must be male and 10% must be female. So I have to maintain this proportion for both of my training set and both of my test set. So that is why we use stratify is equal to true. I hope this much is clear. Now, sir, how to train my model? We have splitted our model. Sir, how to train my model? So first of all, I have to call my model over here. Okay. So I have called my model and saved it as model1. Then we have simply written model1 dot fit. That means I have to train my model1, and in the parameters I have given my training data. That is X train and Y train. In the parameters I have given my training data. That is X train and Y train. And I have simply written model1 dot fit. Now if I will just give some input features, use the standard scaler, and if I try to predict my output with the help of dot predict function, okay, with the help of dot predict function, I am getting the output 0. Okay, this means 0 is nothing but 0 stands for 0 stands for iris setosa. Okay, I am getting the output 0, which means I am getting the output iris setosa. This means that my model is working properly over here. I hope this much is clear. I hope this much is clear, guys. Great, great, great. Yes. So I have to now, like I have pre-processed my dataset, right? Firstly, I pre-processed my dataset. In the second step, I have splitted my dataset into X train and Y train. Okay. Then what I have to do? I have to train my model. Okay. This is a classification problem, so we have to take a classification model only. So I have taken logistic regression as my first model. Okay. I have taken logistic regression as my first model. Okay. Now under logistic regression, I have given I have given the training data set, that is X train and Y train. I have split it into X train, Y train, X test, Y test. Am I right? So I have given the training part to my model with the help of model1 dot fit. Dot fit is used to train my model, and I have given the training data set. Then after that, if I try to predict some kind of output, I am getting the output 0, where 0 denotes that I am getting the output iris setosa. I hope this much is clear. Then I have used, then I have used, like I have taken the predictions. I have taken the predictions on my training data set, that is X-train. Okay. So all the predictions I stored into modeled underscore predictions. Okay. What I have done over here, I have taken the predictions model1 dot predict X train. That means I am finding all the predictions on my X train, and I am storing all those predictions into model predictions. Okay. Then I have used metrics dot accuracy score. This accuracy score will give me some kind of accuracy of my model. Over here, if you can see, it is showing 0.95, which means my model is 95% accurate, which means 95% of the times my model is giving me the correct output. Okay, which means my accuracy of my model is 95%. I hope this much is clear. I hope this much is clear. If everything till now is clear, write clear in the chat quickly, guys. Yes, all these files and all the notes will be shared to you guys, so don't worry. Yes, we can also, this is the accuracy. Um, yes, just Utopia. Okay. So this is the accuracy for training part. Okay. This is the accuracy for training part. In the next step, uh, I have taken the accuracy for testing part as well. So to get the accuracy of testing part, I have taken X test over here instead of X train. Okay, I have taken X test over here. Then I have compared all the values of X test, that is this model prediction test. I have compared all the values of X test with Y test. Okay, and then after finding the accuracy, I am getting the accuracy as 93% on testing part. So we can say we have trained a model in which we have 95% training accuracy and 93% testing accuracy. I hope this much is clear. Similarly, we have trained logistic regression, right? So I have taken model 2 is equal to XGB classifier. So this time I have trained XGBoost model, that is XGB classifier. In the similar way, I have written model 2.fit and I have provided the training part. Then I have saved all my predictions of training part into model predictions and I have calculated the accuracy. So as you can see, the accuracy over here is 1, which means our model is 100% accurate. But sir, can a model be 100% accurate? No. This means if we are getting an accuracy, suppose suppose if we are getting the accuracy 100%, this means our model is too good to be true. This means our model is too good to be true, which means this leads to a condition of overfitting. This leads to a condition of overfitting. Overfitting is the case when we are getting a high accuracy on training data and a low accuracy on test data. When we are getting high accuracy on training data and low accuracy on test data. I hope this much is clear. I hope this much is clear now. And in similar way, we have found the accuracy on test data, that is 93% for XGBoost. Then again, we have trained another model, that is random forest classifier. Like I am training different models to get the accuracy for each and every model, and then I will save the best model. So I am seeing the accuracy for random forest is also 1, that is 100%. And on the training part, it's 93%. Then I have trained SVC, that is the support vector classifier model, again with the help of model 4.fit xtrain ytrain. Again I am getting the accuracy score, that is 97.5, and the accuracy on that is test data, we are getting 96.5. So we can say this is the best model till now, with the training accuracy and testing accuracy almost equal. I hope this much is clear. Yes, without math we can train our model, but actually it is very, very much important to understand the maths behind all of these models. So in this bootcamp, we are not going to discuss about the previous mathematics behind all these models. But if you are really interested, so I have, like, in the previous any of the previous bootcamp, I have explained the mathematical intuition as well behind one or two models. So you guys can go and watch those bootcamps if you want the mathematical intuition of these algorithms. So this is how we can train our models in a very, very simple way. Okay, and we can calculate the accuracy. Sir, sir, I have a doubt. Sir, can we increase the accuracy of our model? Can we increase the accuracy of our model? Yes, we can increase the accuracy. Sir, how? The answer is hyperparameter tuning. We can also increase the model accuracy by improving the quality of the data set and all. There are many ways actually, but right now the best technique is hyperparameter tuning. Now, sir, what is hyperparameter tuning? So, if you just go to any of the model, okay, like let's talk about first of all the logistic regression, okay. So I will just simply go to logistic regression sklearn. Okay. So this is the official documentation of logistic regression model. Okay. So as you can see, in under this logistic regression model, there are some parameters. Can you see these parameters? There are some parameters known as hyperparameters. Okay. There are some parameters known as hyperparameters. So when we enter the value of these parameters by ourselves, okay, so when we train our model, the default values of these parameters are taken, okay. But we train our model if we train our model on non default values, like we give the values by ourselves, then we call it hyperparameter tuning. For example, the first of all, the hyperparameter tuning is done with the help of grid search CV. Okay, so we have to use grid search CV. In the next case, right now just ignore this param grids. Okay, focus on this grid search CV. Deal grid search CV as one of the more models. Okay, deal grid search CV as another model of mine. Now grid search CV, I have to first call this. Okay, first of all, I have to call this grid search CV. Okay, sir. So I have written grid search is equal to grid search CV. Under the estimator part in grid search CV, I have to give my model. Okay. So I have taken model 4 over here. So if you can see, my model 4 is nothing but the support vector classifier model. So under the estimator, I have to give my model name, like which model we are going to deal with. Okay, sir. Underscoring underscoring we have to give the accuracy, okay, that we have to test our model based on accuracy. Okay, we have to test our model based on accuracy. Now, sir, what is end underscore jobs? End underscore jobs means that like how many CPU cores you are allotting to your this model training part. So just remember that if you are giving -1, this means all of the CPU cores are going to perform this training part firstly, then any other task. So your model training will be as fast as possible. If you will give the accuracy, if you will give the value -1. Now, sir, what is verbose? Verbose is how much detailed information do you want on training part? How much detailed information do you want for training part? If I just give the value of verbose, let's say 3 or 5. So this helps me when I want to like debug my models and all. When I want to test my models, debug my model, I'm going to give the verbose 3 or 4, which means I want more and more detailed information on my model. But right now, I don't want any detailed information, so I'm just giving verbose equal to 1. Then CV stands for cross validation. Over here, CV equal to 5 means that my model, my data set is going to be divided into 5 different parts, and my model is trained on all of those 5 parts. I hope this much is clear. Okay. Then, sir, next thing is param grade. Sir, what is this param grade now? So, param grade is the step where we put the values of these parameters. Okay. Param grade is the area where we put the values of these parameters. So right now I'm dealing with model 4, that is my SVC, right? So I will simply go, I will write SVC SK learn. I will open the documentation, and these are the parameters for support vector classifier. Okay. So what I can do, I can apply all the parameters. Okay. Right now I am applying only 3 parameters, that is C, kernel and gamma. Okay. Right now I'm applying only 3 parameters, that is C is over here, kernel and gamma is over here. Okay. So let's see now this first parameter C. So in the C parameter, we can write any float value. Okay. The default value is 1, but we can write any float value. So over here I have taken 4 values, that is 0 0.1, 1, 10 and 100. Okay. So my model will be trained on all of these 4 values of C. Sir, any other thing? Let's take kernel now. So under kernel, we can take many different values as linear, poly, RBF, sigmoid or pre-computed. Okay. The default value is RBF. So what I have done, I have taken 3 values under kernel, that is linear, the second one is poly and the third one is RBF. So the next is gamma. In gamma we can take either scale or auto or any float value, and the default value is scale. So I have taken scale, auto, and I have taken 2 float values, that is 0 0.1 and 1. So this is how we can give our own parameters. Okay, this is how we can give our own parameters for all of these parameters that are mentioned in SVC. For all of these parameters mentioned in SVC, we can give our own parameters. And based on these parameters, we can train our grid search model. Okay, we can train our grid search model, and with the help of this dot best parameter function, we can get the best parameters that are used for our model, and we can get the accuracy as well with the help of dot best score. So as you can see, my accuracy is now 98.3%, but before hyperparameter tuning my accuracy was 97.5%. So can we say that our accuracy is increased? Yes, our accuracy is increased from 97.5 to 98.3. I hope this much is clear now. And similarly, the test accuracy we have seen 96.6. I hope this much is clear now. Sorry if my teaching is very fast, but we have to cover a lot of topics. Okay, let me just explain this once again. Okay, hyperparameter tuning. Hyperparameter tuning is the process in which we give the values of parameters of a particular model. Okay, we give the values of the parameters of a particular model. So right now I am dealing with my model 4. My model 4 is nothing but SVC. Okay, that is support vector classifier. Now what I will do, I will quickly go to Google and I will write SVC sklearn. So I will get all the, as you can see, these are all the parameters that we can give in a support vector classifier model. Okay, so we can change or we can give the values of these parameters. So I have done nothing new. I have just assigned the values, like in C, I can assign any float value. Okay, under the C parameter, I can assign any float value. So as you can see, under the C parameter, I have given the values as 0 0.1, 1, 10 and 100. Okay, then the next one is kernel. Under kernel, we can give the many values like linear, poly, RBF, sigmoid, pre-computed, or any value. Okay, like these values we can give under kernel. So what I have done over here, I have taken three values, that is linear, poly, and RBF under the kernel part, under the kernel parameter. Then I have taken the gamma parameter. Under the gamma parameter, we can take either scale or auto or float, any float value. So I have taken scale, auto, and I have taken two float values, that is 0 0.1 and 1. I I have taken only, I have considered only these three parameters, but I can consider all of these parameters. Okay, so what you can do, you can give the values for all of these parameters, and then based on these parameters we have trained our model. Okay, and we have seen that after training our model, the accuracy is increased, that is we got an accuracy of 98.3%. I hope this much is clear now. Yes, all of this code, all of the notes will be provided to you guys, don't worry. I am doing nothing new, I am just assigning the values of parameters. Okay, I am just giving the values of parameters so that my model can be trained on different parameters, not only the default parameters. Sorry, but we are not going to discuss about the LLM implementation in this bootcamp. But if you want, you can go and watch my previous bootcamp based on generative AI and prompt engineering. There I have discussed the LLMs as well. Great. So in this similar way, I have applied this grid search CV for others as well. Other model, that is model 3. That was my XGBoost or someone, I think so. I have done the same thing. I have applied these parameters. Then I have seen the train the model and I have seen the accuracy and all. Okay. Then again I have applied, just give me a second. Sorry, not this. Yes. Then again I have applied my grid search TV on model 4. Okay, this is SVC only, nothing else. So this is a basic concept, like how can you apply grid search TV. I hope this much is clear. How can you do the hyperparameter tuning? I think so this is clear now. Yes, and by this similar way, you can fine tune any model. Like for logistic regression, you have to take these parameters. For SVC, you have to take these parameters. You can go and find out the same for parameters like for like models like XGBoost or the models like random forest or any model. Okay, I hope this much is clear. Okay, sir. So we have now covered the hyperparameter tuning part. We have seen first how can we train our models, and then we can how can we fine tune our models. Okay, these two topics we have covered. The next topic that we have to cover now, the next topic that we have to cover now is um is ensemble learning. So now what is ensemble learning? We are predicting the this fourth column over here, the species of our flower. Okay, we are predicting this fourth column, the species of our flower, that is iris, whether the species is iris setosa, whether the species is iris virginica or iris versicolor, based on some particular features like these features are like petal length, sepal length, and all and all. Okay, so based on these features we are predicting the species of our flower. Yes, we are applying the updated parameters and model using grid search. Great. So let's move on to ensemble learning now. So, sir, what is ensemble learning first of all? Sir, what is ensemble learning first of all? Yes, yes. So, in ensemble learning is a technique in which multiple models are combined together. Ensemble learning is a technique in which multiple models are combined together to solve a problem, we can say. Okay, are combined together to solve a problem, or we can say better than it is also better than one model. I hope this much is clear. Okay, so this is a very basic definition of ensemble learning. Okay, sir. Sir, why do we need ensemble learning now? Sir, why do we need ensemble learning? So, like when we are using a single model, sometimes we don't get a better accuracy, or sometimes we can just say that we lead to the condition of overfitting or underfitting or else. Okay, so with the help of single model we are very limited to like specific parameters and all. We cannot, let's say I will show you with an example. Okay, just give me a minute, I will show you with an example. Okay, yes, ensemble learning. So yes, I will quickly connect my notebook. Till then, I will just explain you what's the definition. So when we use multiple models, when we combine multiple models together to solve a problem, we call it ensemble learning. Okay, there are basically three types of ensemble learning. There are basically three types of ensemble learning. The first one is bagging. The first one is bagging. The second one is boosting. The third one is stacking. Now let's understand what all are these three types of ensemble learning. So first of all, I will run this model. In this model, I have done nothing. I have just imported all the libraries. I have used the load iris dataset, the same dataset that we have used over here as well. Okay, the same dataset. Okay. Then we have applied standard scaler and we have simply splitted our dataset into training and testing part. And then we have simply trained our model based on logistic regression. Okay. If I will just run this model, you can see the accuracy is 100%. You can see the accuracy is 100% over here. So can we say this is an overfitting condition? Yes, this is an overfitting condition. Now sir, how to deal with this? So with the help of ensemble learning, we can deal with this overfitting condition. So let's talk about, we have three types of ensemble learning. The first one is bagging. Okay. So let's talk about bagging first of all. Sir, what is bagging now? Sir, what is bagging now? In bagging, we train multiple models. Okay. We train multiple models on random subsets of data, we can say. Okay. Like we create random subsets. Suppose. Okay. Let me just give an example. Suppose I have a data set over here. Okay. So in bagging, what I am doing, I am creating random subsets of my of my data. I am creating random subsets of my data, and then I am training my model. I am creating random subsets of my data. Okay. And then I am training my model based on those subsets. I am training my model based on those subsets. Okay. So, like, firstly, I train my model on this subset. Then on the second rotation, I train my model on this subset. Then on the third, on this one. So this is how I'm training my data set. I'm training my model on different subsets. So this is what we call bagging. Okay. So this is we call bagging, in which we train our data set on random subsets. And we generally use random forest. Okay. We generally use random forest as a random forest model. And in random forest is nothing but, if I will just give you an explanation, in random forest we use multiple decision tree models. We use multiple decision tree models. Okay. In random forest we use multiple decision tree models. So that is how we are combining more than one model to get some kind of output, and each decision tree model is training on each, what we call, each data sample. I hope this is clear. Okay. So if I'll just show you with the help of a code. So yes, this is where we are performing bagging. So first of all, I have imported random forest classifier. Random forest over here consists of different decision tree models. Okay. And I have just simply trained, just an estimator is nothing but a parameter. Like we done the hyperparameter tuning, right? So we have put at the value of n estimator is equal to 100, and I am simply training this model. And as you can see, I am getting the accuracy of 95%, which is a good accuracy as compared to this 100%, because this is leading to overfitting condition. So this 95% accuracy is a good accuracy, and this is how we perform bagging. I hope this much is clear. I hope this much is clear. If everything is clear, write clear in the chat quickly, guys. Great. Then the next part is boosting. The next part is boosting. So under boosting, yes, under boosting, the output in boosting, in boosting, the output of first model. Okay, the output of first model, or better way to say that, in boosting, the second model is used to correct the first model. In boosting, the second model is used to correct the previous model, the output of the previous model. Okay, this is how boosting works. If I will just show you an example of boosting. So yes, as you can see, I have imported ADA boost classifier. There are different types of boosting actually. So the first one is ADA boosting. We can also use what we call it, XG boost. Okay, we can also use XG boost as well. But right now I'm using ADA boost classifier. It is also a type of boosting algorithm. Okay, and we have applied decision tree classifier. Okay, we have imported two algorithms. The first one is decision tree and the second one is ADA boosting classifier. Now what I have done, I have implemented ADA boost classifier and my estimator is decision tree classifier. Sir, what do you mean by this? This estimator over here is saying that my first model is decision tree, and based on the output of decision tree classifier, I am training my boosting classifier model. Okay, like based on the output of one model, I am training my second model. And if I will just see the output, it is giving me same 95% accuracy. I hope boosting part is also clear. Like based on the output of one model, I am training my second model. If everything is clear till now, please write clear in the chat. The code you will not be able to understand until you do it by yourself. Okay, so I would highly recommend you guys to practice the code side by side, or after the lecture, just open the YouTube and open the lecture once again and try to code it by yourself, because without doing the code by yourself you won't be able to get it. The next part is, we have discussed bagging and boosting. The next algorithm we have to discuss is stacking. Okay, so in stacking, yes. Yes. So in stacking, yes, I have to write over here. So in stacking, I have multiple models. Okay. I use multiple models. I use multiple models and then combine the output of all the models using one final model. Okay, try to understand. I have many models. Okay, my all of my models are working on or training on the dataset, and then I'm using a final model to combine all the outputs of the all the working models. Okay, in stacking all the models. Okay, in stacking, yes, in stacking we have different types of models and we combine all the outputs of these models using another model. Okay, and this final model is known as meta learner. We combine the output of all the models into a single model and we call that model a meta learner. And similarly, if I will just show you the example, So I have used the model stacking classifier and logistic regression and SVC and k nearest neighbor, k neighboring classifier. Okay, so these are all the four models that I have used. And as you can see, what, so now I've used this base learners. So what is this base learners? So I've told you, right, the final model we call it meta learner, right? The final model we call it meta learner. But sir, what about these multiple models that we are using? These multiple models are known as base learners. These multiple models are known as base learners. So I have written over here base learners. I'm using these two models as my base learners. Then I have used logistic regression as my meta model. Then I have created a stack model, okay, with the help of stacking classifier. I have made a stack model under which I have given the estimators as my base learners and final estimator as my meta model. That, hey, the final model that I am using to combine is my meta model, and all the other models that are giving me the output are my base learners. That is all SVC and K neighbors classifier. And with the help of like dot fit again, I am fitting my model, and at the end I am getting the accuracy of 95. Okay, these are the three ensemble techniques. Okay, these are the three ensemble techniques. First one is bagging, second one is boosting, and the third one is stacking. I hope everything is clear till now. I hope everything is clear till now. Great, great, great. So yes, everything is clear. Now for the attendance link. So the attendance link is there in the chat. Okay, it's not there. Just give me a second. I don't know, it's not pasting. Just give me a second, guys. Okay. Guys, the attendance link is there in the chat. So if anyone, so all of you guys must go and fill out today's attendance. Okay. The attendance link is there in the chat, and it is very much important for the certificates that you must have filled the attendance. Yes, actually, data science field is like the combination of machine learning, deep learning, generative, and all. So we can say that this is a base of data science only. Thanks a lot for joining today, guys. Quickly fill out the attendance. Thanks a lot, everyone. Thanks a lot. Yes, in tomorrow's lecture we will be discussing about the deep learning concept only, like what are neural networks and how can we train our model using neural networks. Of course, I'm not going into that much details in deep learning and neural networks because we only have 1 hour or 1.5 hour. So, but I will be like explaining the concepts in like in a broader view. If you have missed 1 or 2 session, don't worry. Everything regarding the certificates criteria or anything else will be shared at the end. Guys, please quickly fill out the attendance form. It's there in the chat. These models are predicting the type of flower, the flower species. There are like we have seen 3 types of species. The first one is Iris setosa, virginica, and Iris versicolor. So these are predicting these 3 species. If you have missed any of the attendance form for any of the day, don't worry. We will discuss everything regarding the attendance and everything in the last lecture, that is day 5. That will be day after tomorrow. So right now, please fill out the attendance form for today. Okay, I will try to take the next bootcamp on computer vision and neural networks. Okay. Guys, please fill out the attendance form. It's there in the chat. Quickly fill out the attendance form. Okay, I will try to conduct a boot camp on computer vision as well. Don't worry. Yes, the notes will be provided. It will be most probably it will be provided in the community only. So please stay updated in the community. Check the description time to time. If you have missed any of the attendance for any of the day, don't worry. I will deal that problem in the last year. That is day 5. So please fill out the attendance for other days. Yes, those who have filled out the attendance form, they can leave. This lecture is for like I'm just going to over the lecture soon, and let's meet tomorrow on the same time. That is 7 o'clock. And tomorrow we will be going to learn a little about neural networks and how to train using neural networks. Okay. Thanks a lot for joining, guys. Thanks a lot. Please fill out the attendance. Regarding the okay. Yes, regarding the project, actually, we are making the classification. Like we have seen classification. I will try to show you regression as well, and I will show you the neural networks training. Okay. So basically, we will be knowing that we can train any model now. Okay. That because we know classification as well, regression and neural networks a little bit. So I am just going to train a model on any of the data set, but you can also train model on any, like if you want any other model, like if you want to train any of the other data set, you can train on that particular data set as well. It is not like we have to or we all have to make a specific project only, but you can make different projects as well. Thanks a lot for joining, guys. Please fill out the attendance form for today's session quickly. Thanks a lot for joining, guys. Let's meet tomorrow in tomorrow's session, that is day 4 at 7 o'clock. Thanks a lot.